Welcome. You're about to embark on a journey into the world of programming. This video is your first step. We'll cover the basics, what programming is, why it matters, and the key concepts that get you started. Get ready to think like a programmer. This isn't about becoming an expert overnight. It's about understanding the fundamental ideas. We'll use simple language and clear examples. By the end, you'll have a solid foundation to build upon. Let's begin. The first thing we need to do is define what we mean by programming. In the simplest terms, programming is giving instructions to a computer. These instructions are detailed and precise, ensuring that the computer knows exactly what to do. Think of it like writing a recipe. When you write a recipe, you list out each ingredient and step in a specific order. You list out the steps, and the computer, like a chef, follows them precisely. Just as a chef needs clear instructions to create a dish, a computer needs clear instructions to perform tasks. Except instead of delicious food, the computer produces things like websites, apps, and even video games. These digital creations are the result of carefully written code that tells the computer exactly what to do. The instructions we give computers are written in a special language called a programming language. These languages are designed to be understood by computers, allowing us to communicate our instructions effectively. Just like humans use different languages to communicate, programmers use different programming languages to communicate with computers. Each language has its own syntax and rules, much like spoken languages. But don't worry, we'll explore those languages soon enough. There are many resources available to help you learn, from books to online tutorials. For now, just remember, programming is about breaking down a task into small, logical steps that a computer can understand and execute. This process involves careful planning and problem solving, ensuring that each step is clear and unambiguous. By mastering this skill, you can create anything from simple scripts to complex software applications. Debugging is another crucial aspect of programming. It involves finding and fixing errors in your code to ensure everything runs smoothly. Just like a chef might taste and adjust a dish, programmers test and refine their code. Over the years, programming has evolved significantly. From the early days of simple machines to today's advanced technology, programming has been at the heart of innovation. It has enabled us to build everything from basic calculators to sophisticated artificial intelligence. Learning to program can be a rewarding experience. It not only enhances your problem-solving skills, but also opens up a world of opportunities. Whether you're interested in web development, game design, or data science, programming is a valuable skill that can take you far. The programming community is diverse and collaborative. Programmers often work together, sharing knowledge and solving problems as a team. This sense of community can be incredibly supportive, especially for those just starting out. As technology continues to advance, the possibilities of what we can create with programming are endless. From virtual reality experiences to smart cities, programming is shaping the future in ways we can only imagine. So, whether you're a beginner or an experienced coder, remember that programming is a journey of continuous learning and creativity. Embrace the challenges, celebrate your successes, and keep exploring the incredible world of programming. There are many programming languages, each with its own strengths and weaknesses. Some popular ones include Python, Java, and C++. Think of them as different tools in a toolbox. Python is known for its readability and beginner friendliness. It's often used in data science and web development. Java is popular for building Android apps and enterprise-level software. C++ is a powerful language used for game development and systems programming. The choice of language depends on what you want to build. Don't get caught up in picking the best language. The key is to learn the fundamental concepts that apply across all programming languages. Imagine a box where you can store things. In programming, that box is called a variable. You can give it a name and put different types of data inside, like numbers, text, or even lists of items. For example, name equals Alice and age equals 30. Here, we created two variables. Name stores the text Alice, while age stores the number 30. We can then use these variables later in our code to access the stored information. Variables are essential for manipulating and working with data in our programs. They act as placeholders for the information our programs need to operate on. Controlling the flow. Control structures. Just like a cooking recipe might say bake for 30 minutes at 350 degrees, programming languages have ways to control the flow of instructions. These instructions guide the computer on what to do next, ensuring that tasks are performed in the correct order and under the right conditions. These are called control structures. They are fundamental building blocks in programming that help manage the flow of a program's execution. Two common control structures are conditional statements and loops. These tools allow programmers to create complex and efficient code by controlling how and when different parts of the code are executed. Conditional statements, like if-else, allow our program to make decisions based on certain conditions. For example, an if-else statement can check if a user is old enough to access certain content. If age is greater than or equal to 18, the program might allow access to a website or feature. Else it might display a message saying access is denied. Loops, on the other hand, repeat a block of code multiple times. This is useful for tasks that need to be performed repeatedly, such as processing items in a list or generating repetitive outputs. For I in range 5, the loop will execute the block of code 5 times. This code will print hello 5 times, demonstrating how loops can automate repetitive tasks efficiently. Control structures give our programs the power to be dynamic and responsive to different situations. They enable us to write code that can adapt to various inputs and conditions, making our programs more versatile and powerful. By mastering control structures, programmers can create more sophisticated and efficient software that can handle a wide range of tasks and scenarios. Building blocks of code. Functions. Imagine having to write the same code over and over again. Functions solve this problem. A function is like a mini program within your program. It performs a specific task and can be reused multiple times. For example, def greet, name, print, hello, name, plus, greet, Alice, greet, Bob. This code defines a function called greet that takes a name as input and prints a greeting. We then call the function twice with different names. Functions make our code more organized, reusable, and easier to manage. A simple program, putting it all together. Let's combine what we've learned to create a simple program, a culmination of all the concepts we've covered so far. This will help solidify your understanding and give you a practical example to refer back to. We'll start by defining a function in Python. The function will be called calculateArea, and it will take 2 parameters, length and width. This function will calculate the area of a rectangle. Def calculateArea, length, width. Next, we'll assign values to these parameters. Let's set length to 5 and width to 10. These values will be passed to our function. Length equal 5 width equals 10 area equals calculateArea, length width. Finally, we'll print the result using the print function. This will display the area of the rectangle on the screen. Print, the area is area. This program defines a function called calculateArea that takes the length and width of a rectangle as input, calculates the area, and returns the result. The function uses a simple formula, area equals length multiplied by width. We then call this function with a length of 5 and a width of 10, store the returned area in a variable, and finally print the result. The output will be the area is 50, which confirms that our function works correctly. This simple example demonstrates how we can use variables, control structures, and functions to create a program that performs a specific task. By breaking down the problem into smaller, manageable parts, we can tackle more complex challenges with ease. It's important to remember that programming often involves debugging and refining your code. Don't be discouraged by errors. They are a natural part of the learning process. Each mistake is an opportunity to learn and improve. Testing your code on different devices and scenarios ensures that it works as expected in various environments. This practice helps you build robust and reliable programs. Collaboration and teamwork are also key aspects of programming. Working with others allows you to share knowledge, solve problems more efficiently, and create more innovative solutions. Continuously learning and staying updated with the latest programming trends and technologies is crucial. There are numerous resources available, such as books, online tutorials, and workshops, to help you keep your skills sharp. As you progress, you'll be able to tackle more complex projects and challenges. The foundational skills you've learned will serve as a strong base for your continued growth in the field of programming. Remember, the journey of learning to program is ongoing. Each project you complete, each problem you solve, and each new concept you master brings you one step closer to becoming a proficient programmer. So, keep practicing, stay curious, and enjoy the process of creating and problem solving. Happy coding! Keep exploring. The journey continues. Congratulations! You've taken your first steps into the world of programming. You now have a basic understanding of what programming is, how it works, and some of the key concepts. Remember, this is just the beginning. There's so much more to learn and explore. Practice writing your own code, experiment with different concepts, and don't be afraid to make mistakes. That's how you learn and grow as a programmer. Keep that curiosity alive, and you'll be amazed at what you can create with the power of programming. Don't forget to like and subscribe to our channel for more content.